Welcome and hello. This is a video tutorial in MODSIM, and in this lesson we're going to be talking about hydropower plants, specifically the high-head hydropower plants. All right, what I have on the screen is my MODSIM user interface. I'm going to sketch a reservoir onto the screen here and call it Res1. To start, I'm going to describe what is a hydro plant, or really the difference between a high head hydro plant and a run-of-the-river hydro plant. I've got the reservoir properties editor box open right here to the general tab already. A high head hydroelectric plant is probably what you're thinking of a power plant. It has a high head water that's tens or hundreds of meters high. Its flow rate is controlled by the reservoir dam. It's a large reservoir and it has a low dependency on the river flow. Conversely, there is what's called a run-of-the-river hydroelectric plant, which can also be modeled in MODSIM. These are low head, usually just a few meters. They have limited or no flow control, small reservoirs or no reservoirs at all, and they are highly dependent on river flow. So we'll probably talk more about run-of-the-river plants in another lesson. This lesson here will be focusing on the high-head hydroelectric plants. All right, so let's get to the actual lecture here now. The user's manual here on page 42 has this equation 10. This is the power generated at the hydroelectric plant, KQHE. So the product of these factors here is the power generated. The Q right here is the flow rate, H is the effective head, E is the efficiency of the power plant, and that's a function of the flow and the head. And then K right here, this is a conversion factor, which accounts for the density of water and the gravitational acceleration. There's also this P max right here. So regardless of how high your factors are, like your flow and your head, the power cannot exceed the maximum power of the power plant. Okay, so let's go to our MODSIM. Here is the main user interface. Here's the general tab. Off camera, I went ahead and just added some numbers in here. And I'm also going to add some numbers in here for the reservoir geometry. Right click and paste table. Okay, so there's some data there. Now that that's set up, I'm going to click on the Power tab. The Power tab does require the reservoir geometry data, the area, capacity, and elevation for high-head hydroelectric plants. So let's go ahead and hit Apply to save that. All right, onto the Power tab. That maximum power that we saw from equation 10 that we were just looking at, you can put that in right here. So something like 20 kilowatts. Oh, kilowatts. Okay, so in that case, if I'm thinking megawatts, it would be 20,000 kilowatts, or maybe something like 50,000 kilowatts or 50 megawatts. Back to this equation here. The flow rate, we'll know that. That's the release through the reservoir. The head, that'll basically, the effective head is what it's called. That's basically the difference between the water surface elevation minus the tailwater elevation. And then also you'd have to account for some minor losses or friction losses within the hydroelectric plant itself. And then we have the efficiency. We'll talk about that later. As for this head, the head may actually differ based on the water surface elevation, which is changing over the time period of evaluation. So if you scroll down here to equation 11 on the next page, this is page 43 now, we have this equation 11 for the mean effective head, which equals basically the average elevation at the beginning of the time period and the end of the time period, and then minus the tailwater elevation. The elevation in the reservoir, water surface elevation, is a function of the storage. So this time period T is the beginning of the time period. T plus 1 represents the storage and hence the elevation at the end of the time period. Or you could just say it's at the beginning of the next time period, same thing. That way, MODSIM will iteratively find what that effective mean head is for the time period involved through an iterative process and using the storage and the elevation curve from the reservoir geometry, which we added into our capacity tab within the reservoir properties. This E sub P here is a constant term. That's the elevation of the power plant. Again, this is sort of assuming a constant tailwater condition. If it's not a constant tailwater condition, you'd use this equation down here, equation 12, which is basically the same thing as equation 11, except this last term doesn't subtract a constant term. It's based on the flow rate. So your tailwater for reservoir I at time period T, as I is for the reservoir subscript, T is for the time period subscript, is a function of Q. That's the release through the reservoir. So let's go ahead and check that out within MODSIM. Here is our power tab. Once again, all we've done so far is added the max power. And then down below that, we put the power plant elevation, and the elevation type is either constant, that would use equation 11, or it would be a variable. So the other option is variable right here. If it's constant, then we could just go ahead and type in whatever the elevation is for the power plant. We'll just say something like 700. But if it's variable, then we would actually have to enter a table where that tailwater elevation would be based on the release. So that looks like this right here. And if I was going to just paste in some data I had copied on my clipboard from Excel, boom, here's an example table. So as the release or the outflow increases, so does that tailwater elevation. I just made those numbers up. All right, next in the user's manual, a little further down, we have an equation for the energy generation. That's right here. Basically, the energy generation, there's two calculations, just like was for the average head, but this time it's based on peak generation versus non-peak generation. This delta TP, superscript P, is the time that the power plant is running on peak energy generation. That's what it says right here. And then if you scroll down to the next equation, 14, the delta T term is the total time that the power plant is running minus the time that it is running on peak power generation. So this term right here is basically the duration of time the power plant is running, hydroelectric plant is running on off-peak generation. So energy is just power times time. That's what we're seeing here. P, we already calculated that earlier, and then the time that the power plant is running. Again, this is for off-peak. Then we come up here. This is for peak power generation. We can control the number of generating hours in MODSIM by clicking this button, Gen Hours. Then the numbers that we put into this table here is the delta T peak hours for each time period. So we've seen a table like this before in MODSIM where we enter the value and then the start date and then the units and whether it varies by year or not. So for the month of January, for instance, it says 744 hours. That's the total number of hours in January or in any 31-day month. But we could dial it back and just say 200 hours in the month. So that's about 6 hours a day or 7 hours a day. And then, yeah, we can change the units as well. So here's, well, I guess hours is fixed, but then the time period would be something less than month, down to second. Probably something like hour, day, or week. But of course, you'd want to change your number here. If the peak hour changes from month to month or just any other time period within the year, you can add additional rows to this table. But I'm just going to leave it as it is for now and then delete what I've already created here. Okay. Then click apply and click OK. There's also this checkbox right here, peak generation only. If you only want your power plant running during the peak generation hours, go ahead and click that checkbox, in which case there's going to be no release or flow out of the reservoir during non-peak generation hours. In reality, you really can't have periods of zero release from the reservoir. So if you're going to be using this checkbox option for peak generation only in MODSIM, a re-regulation reservoir immediately downstream is required to provide consistent flow rates downstream. So if you uncheck this checkbox, then it allows MODSIM to release water during off-peak hours. You can generate power at off-peak hours, and that's the default decision. All right, further down we have power plant efficiency. So what we have is some data to define the efficiency of the power plant. Not every power plant is 100% efficient. Typically, you're going to see efficiency values ranging around 70 to 80%, I think, sometimes 85, I guess. And then based on the efficiency, let me go back to that equation here. Yeah, so right here, this is the first equation we looked at. This E term, the efficiency is based on the flow rate and the head. It's going to range between 0 and 1. And that's what we're defining in this table right down here. So before we actually populate the table, let's go ahead and set the units. And also mention that what we're doing is defining this table. It starts us off with this default table called Power EFF. I'm going to call it, how about EFF table 1. That's just the name I'm going to give it. And then if I wanted to save that or create a new table, there's some controls right here to do that. We'll do that at the very end. Let me go ahead and define this F table 1 data. For the head units, I'm going to just leave it at feet. And then for the flow units, I'm going to change this to acre feet per month. And then for the number of head and the number of flows, this basically represents the number of rows and the number of columns in this table down here. Right now, it's just started me off with sort of a generic 2 rows and 2 columns with values from 0 to 1,000 in both rows and columns. And this is something that is going to be unique to each power plant, of course. So you need to sort of think about what is the appropriate range of head and flow rate to define the efficiency. So to do that, I'm going to get the range of tailwater values first. So for me, up in this table, the minimum tailwater is 700, the maximum is 714. And then I need to also, so I'm calculating head is what I'm thinking, not flow right now. And then the maximum head or the water surface elevation, that would be in my reservoir geometry tab. That's going to range from 500 up to 1,000. Now, if the water surface elevation is down at 500 and the tailwater is up at 700, of course, I'm not going to be generating power in that situation. But I could say that the minimum water surface elevation to run the hydroelectric plant would be something like 800 feet. So I'd say like this is the minimum water surface elevation. 1,000 is the maximum water surface elevation. So if we go back to the power tab here, the minimum head would be 800 minus 714. That's 86. And then the maximum head would be 1,000 minus the minimum tailwater. That's 700. So the maximum would be 300. So from 86 up to 300 is my range that I want for head. And then the range for flow, I'd probably start at 0 and then just increase it to whatever the capacity is for the power plant as far as the maximum flow. I'm just going to arbitrarily say that the max flow is 100,000 acre feet per month. So we'll divide that into 6 separate flows. I'm going to change this number of flows here to 6. That's going to give me 6 columns. So it'll be 0, 20K, 40K, 60, 80, and 100. And then the range of head, again, I'm going from, let's go from 0 up to 350. Even though 300 is the max, there's no harm in extending that range of the table a little bit further. And then if I subdivide by 50 feet, that would be 8 different number of head. I'd have 8 rows, so I'll put an 8 right there. And then thankfully, I can extend this table here so I can see what I'm working with. And then over in Excel, I've copied onto my clipboard a table I've prepared. And I'm just going to go paste table. And now I have my flows across the top from 0 to 100,000 acre foot per month. My heads ranging from 0 up to 350. That's in units of feet. And then I have my efficiency values shown in this table right here, which is 0.68 up to a max of around 0.84. Yeah, I think that's the highest one there. That's the sweet spot. All right, so that's how it works. Once we have our table defined, I'm going to save this. So I'll just click on Save Table. That's saved, and it's now in this dropdown. Looks like I still have Table 1 right here. So I can click on Table 1. Oh, it's the same table. All right, cool. So let's go ahead and delete Table 1 and delete. Okay. Now I am left with this table here. Would you like to save the changes? Yes. Okay, so there's that table. If I wanted to create another table, I just click on New, and now here's another table. I can call it F Table 2. I could define the properties, click Save. That's saved. If I want to go back to my first table right here, boom, there's that data. And this efficiency table is saved in MODSIM, so I can click Apply. Okay, it's not unique to this reservoir. I can create a new reservoir, Properties, click on Power, and then I still have the same list of efficiency tables right here. It's not unique to a specific reservoir. Well, that's it for this exercise. What we did was define the properties associated with a hydroelectric plant, a high head hydroelectric plant in MODSIM.